Okay, so we'll start with your Arduino. I'm going to create a little example of hooking up two light dependent resistors, also known as LDRs. So the idea of that is that by changing the amount of light that's falling onto those LDRs, you can measure changing voltages. So in that way, it becomes a very simple instrument where with moving your fingers over them, you can get changing voltages. So we're going to set this up in such a way that we can measure that we can get that information from the Arduino. And once we've done that, the idea is then to hook up the data, the information to Ableton Live, so that actually we can directly in Ableton Live control some simple music making instrument, a small electronic instrument, so to say. And in order to show how that connection works, what we'll also do is actually hook up a number of LEDs, which will light up then depending on certain settings in Ableton Live. So that means that then we have a small instrument, and also we can actually have some visual feedback in relation to Ableton Live. So first of all, I'm going to hook up these LDRs with two wires that go to analog inputs. So the power supply, we will take 5 volts coming from the Arduino as well. And finally, we should connect the ground. And of course, it's important to use the known color coding: red for plus 5 volts and black for ground. I see actually I made a mistake myself here, connecting the resistors to the red wire where they should be the blue or black wire. Okay, so this is the first step in creating our input instrument. And now I'm going to write a bit of code. I'm going to write some Arduino code to deal with the incoming sensors. So the amount of code that we need to write is rather straightforward. It's not too difficult. The first thing we need to do is make sure that the serial port is going to be updated or is going to be started. So in the setup routine, we need to set serial.begin with a specific rate, speed rate, and 9600 is a fine value for that. In the loop which is going to be continuously running, we will be sensing the actual sensors. So what we need to do there is monitor the analog inputs, the first and the second one. And we can do that using an analog read function, which looks at a 0. I forget something, because what I should do, of course, is create a variable. I will call it LDR1, so light dependent resistor number 1. And I can simply copy this line and paste it on a new line so that we can actually read the second LDR, which I will name LDR2. So what we then need to do is print out the information onto the serial port. So with the serial.print command, it is then possible to pass the value of the first LDR, and using a space, so again using serial.print with a space between quotes, it will then print that actual space, and after that I can print LDR2. Here actually I choose print line because not only it will print any information, but also it will automatically go to a new line. And just for the sake of stability, sorry, this is wrong. For the sake of stability, I will put a small delay of 100 milliseconds. And once I've chosen the correct boards and port, I should be able to upload this code. Let's save it to desktop. It is now compiling the sketch, and it shows that it is uploading. And it's actually done uploading. So as soon as we will open the serial monitor over here, we should be able to see the values coming in, and indeed that is the case. And then as soon as I interact with the sensors, we see changing values. So that seems to be working just fine. Okay, so we're going to next step show how to build a small instrument in Ableton Live, which will take the information from the sensors we've just connected to the Arduino board. So what I will do is make a max instrument. This allows us to actually program something ourselves. So I will instantiate a new max instrument, and it shows me this small patch, which is a beginning point of something that needs to be created. And I will make it a little bit larger and zoom in so that it is better to see. So here we can indeed build our own instrument. So I can take away what we don't really need over here, and then what I do need is a serial object, because the serial object will eventually take the information from the Arduino. So by using the print command, I can also see in the max window over here which are the available ports, and the last one, port D, is the serial port. Now in the Arduino code I have specified a speed, a default speed of 9600. It's important to do that here as well. And at that moment, as soon as we will start triggering information from the serial object, but in order to do this, I will use an Ether UI, a so-called Ether UI, connect it to the serial port, and then I can choose where are we? Pull enable. Indeed, if I put this to 1, then we should be able to print the information into the max window to verify that the connection is made. And indeed, we see the max window reporting data. Now, this data needs to be decoded, because it is actually ASCII values that are printed from the serial communication of the Arduino itself. So the recipe is the following. I know that the values 10 and 13 are representing the hard return at the end of the two values being reported. So I'm going to use that to group together everything which is not 10 nor 13 coming from the right outlet, so that as soon as I dump this information from ZL group, I can actually see a sequence of values that represent something that I can decode. Well, the decoding happens basically using an I2A object, which turns this sequence of integers into actual ASCII values. And indeed, then I start to recognize two values which responds also to my movement based, or the movement close to the sensors. The last thing I need to do is use a from symbol object so that the quotes are being removed, and then I have two values that represent the two sensor values coming from the Arduino. So it is, in a way, as simple as that. This patch can also be made in PD. Of course, then it won't run within Ableton Live. Then you will need to use the COM port object. Now, how to turn this into a little instrument? I thought to do the following, which is to use the rect object, which generates a square wave. I can set a default frequency and a default pulse width. I'm going to multiply it with 0.1 because it tends to be quite loud by itself, and if I connect it here, we should already be able to hear 100 Hertz tone. If I change the frequency, then it is much higher, of course. So that seems to work. Now, not only I want to do this, but also I want to be able to change the loudness using one of the sensors. So I'm going to use a multiplication object for that. And moreover, I want to change the frequency. And the way that I'm going to do it is to actually use MIDI values, so that with the MIDI to frequency conversion, I can then imagine this information coming from the sensor to be MIDI values that I will scale accordingly. Now, with the Z map, I have already seen before that the values are in the range more or less from 150 to 800. And if I map that for a frequency range to be in the range 60-90, then ZMap takes care of that. So I can directly connect it there. So the other sensor, I'm going to duplicate this object, is going to be used for loudness. So I will scale the output range from 150 to 800 to, the input range to a new output range from 0 to 1. Also, I noticed that actually while using a linear range for MIDI, changing the frequency is perfectly fine. For loudness, that is not so much the case. So instead of using that, I will actually basically square the values by multiplying them to itself, which gives me a better, say, non-linear feel about in terms of the change of loudness. Now, let's see if this is working. I hear already kind of a changing tone. So this is the loudness. And this is the frequency. If I take a little bit of light from here, so that seems to be working just fine. The last thing I could do or should do is simply save this so that it becomes directly available as a device for Ableton Live. I could call this 2 LDRs to oscillator, and then from that moment on I have an instrument called 2 LDRs to oscillator, which is now working in the context of Ableton Live. So as soon as I open or start the polling, indeed this is then giving me the information.